Look at this for 1 second. 7, 3, 9, 1, 5. Now look away. Can you say all 5 back in the right order without peeking? Most people can, barely. Usually with a pause and maybe 1 digit swapped out of place. Now here's the part that should bother you. A young chimpanzee can watch a screen flash 9 random numbers, scattered across random positions for less than a quarter of a second. Watch them all get instantly covered by blank white squares, and then tap every single one in perfect numerical order from memory, correctly almost every time, faster than you could finish reading this sentence. You would lose to that chimp. Almost everyone does. And the strange part is that this isn't a chimp being smarter than you. It's the receipt for a trade your ancestors made a very long time ago, and you got stuck holding the worst half of the deal. This kind of memory is sometimes called a photographic or snapshot memory, and chimpanzees, especially young ones, are dramatically better at it than adult humans are. Researchers running these exact number tests have found something almost embarrassing. Trained memory athletes, people who compete professionally at memorizing decks of cards and strings of digits, still can't consistently beat a chimp at this specific task when the numbers flash for a fraction of a second, with no time to use any memorization technique at all. The chimp isn't using a trick. It's just seeing the whole layout at once and holding it, the way you might glance at a photograph and remember roughly where everything was sitting in the frame. This isn't really a fair fight in the way it first sounds, and that's part of what makes it so interesting. Most adult humans can only reliably hold around 4 to 7 separate items in working memory at any given moment, which is exactly why phone numbers got split into chunks instead of one long unbroken string in the first place. A chimp tested on the number flash task isn't holding more information in that same kind of working memory. It's relying on something closer to a fast visual snapshot buffer, a brief, almost photographic afterimage of the whole screen that fades within a second or two if it isn't used immediately. Adult humans still have a version of this buffer too. It's part of how you can glance at a room and instantly know roughly where things are, but yours empties out far faster and holds far less detail than a chimp's does, almost certainly because so much of your brain's resources got reassigned somewhere else entirely. You used to be closer to this than you think. Human toddlers, before language really takes over the brain, show some of that same raw visual snapshot ability, holding on to images and spatial layouts with a kind of immediate clarity that mostly fades as they get older and start talking in full sentences. Some young children can glance at a picture book once and correctly point to where a specific small detail was on a page they haven't seen in days. A skill that quietly disappears for most people somewhere around the exact years they're rapidly building vocabulary and grammar. The leading idea here, called the cognitive tradeoff hypothesis, suggests your brain didn't just add language on top of everything else for free. It paid for it, and one of the things it paid with was exactly this kind of fast photographic snapshot-style memory. Here's why that trade made sense even though it feels like a downgrade. Brain tissue is metabolically brutal to run, burning a disproportionate share of your entire body's energy just sitting there idling, let alone actively processing anything. That means any new mental ability your ancestors evolved essentially had to be paid for by deprioritizing something else because there wasn't a way to simply add more capability for free. Language is unbelievably expensive to run. Tracking grammar, holding a sentence's structure in mind while you're still building it, juggling abstract meaning, sequencing words in an order another person can actually decode, all of that demands an enormous constant amount of working memory and processing power. There's only so much of that to go around in a single brain, and something had to give. It's worth saying that chimps aren't walking around with some kind of useless memory superpower either. In the wild, that same fast spatial memory helps them track the locations of hundreds of individual fruit trees scattered across a home range that can stretch for miles, remembering which ones are likely to be bearing fruit in any given month, all without writing a single thing down or telling another chimp where to look. A species that could talk, plan together, warn each other about danger 3 valleys over, and pass detailed knowledge down to children who'd never personally seen the danger themselves, had an overwhelming advantage over a species that could only navigate its own world by perfectly remembering it alone, with no way to hand that knowledge to anyone else. Snapshot memory is genuinely impressive. It just doesn't compare to being able to say, Don't eat that root, your cousin died from it last winter, and have everyone immediately understand and remember it for the rest of their lives, without ever having to personally encounter the danger at all. This is why you can recount in detail an entire conversation you had yesterday, who said what, in what order, with what tone, but you almost certainly couldn't accurately redraw the layout of the room you had that conversation in. Your memory isn't broken. It's just been redirected almost entirely towards sequence, narrative, and meaning, the exact things language is built on, and mostly away from raw spatial snapshots. The exact thing a chimp's brain is still optimized for. It's also why memorizing a string of random numbers, like a new phone number or a verification code, feels so disproportionately hard. You're trying to force information through a system that was built for stories and structure. Memory champions actually exploit this directly. The techniques they use, building an imaginary house and placing each number somewhere inside it, turning digits into characters doing absurd things in a story, work specifically because they convert a raw snapshot task into a narrative one, dragging the numbers over into the part of your memory that's actually still strong. They're not beating the chimp at its own game. They're refusing to play that game at all and switching to the one your species actually specializes in. This same swap shows up at a much bigger scale than just numbers too. A chimp's memory has to live entirely inside one skull with nowhere else to put it. Yours doesn't. The moment your ancestors could talk, they stopped needing to personally remember everything perfectly, because they could store it outside their own heads instead, in other people, in stories repeated around a fire, eventually in symbols scratched onto stone or written on a page. A skill doesn't have to live in your memory anymore if an elder remembers it for you, or a piece of paper does, or now an entire device in your pocket does. You traded a flawless internal snapshot system for a much messier one that barely works alone, but that was never the point. It works because it's built to be shared, copied, and stored outside of you, across an entire group, instead of trapped inside a single, eventually mortal brain. There's something almost funny about how this plays out today. An entire industry of sticky notes, phone reminders, and whiteboards exists basically to patch over a memory weakness your own ancestors traded away on purpose, in exchange for being able to talk. Meanwhile, a chimp in a research enclosure can glance at a random number grid once and never need a sticky note for anything in its entire life, mostly because it has nothing it urgently needs to tell anyone. None of this means you're somehow worse off than a chimp, even though it might feel that way the next time you forget a 4-digit code you just read 30 seconds ago. It means you're running a brain that was rebuilt almost from the ground up, around an ability no chimp will ever have. You can describe a sunset to someone who's never seen one. You can warn a stranger about a danger you encountered and they never will. You can read words written by someone who died centuries ago and walk away knowing something they knew, without either of you ever sharing a single moment of actual time together. A chimp can beat you badly at a number flashing memory game and still never once manage any of that. You gave up a kind of memory that fades within a few hundred milliseconds in exchange for being the only species that can hand its knowledge down across generations it will never personally meet. Most days, that still looks like the better deal, even if it does occasionally cost you your keys.